we ran into these last two examples, and you're going to have similar ones for your homework where you're doing the bootstrap method in order to come up with a confidence interval. So there is one version that does a single proportion, and there's also a version that does a single mean. And so what you'll do, I'm going to be doing the teen problem with anxiety/depression. And I'm going to run 1,000 samples, bootstrap samples, because keep in mind, there's really only one original sample that's acting as a representation for our population. And we're going to get the shape, we're going to get the center, the SE, and then we're going to come up with the confidence interval. But over in StaKey, these are the new things that we're using to do bootstrapping. And I'm doing confidence interval for a single proportion. And what we're doing here, again, is estimating the proportion or the percentage of teens that say anxiety or depression is a major problem. And when you look at here, as far as your choices of data sets and variables, you have the young adults. No, not that one there. It is right here, teen problem, anxiety/depression. And when you click on that one, it will show you the original sample here, but we need many samples. And Bootstrap is a way to generate more samples based off of this original sample. And what you need to do is click on one of these. And right now we're just going to generate 1,000 bootstrap samples. And when you clicked it, it's going to give you everything that you need. One is the shape is bell shaped. Also, we've got what the best estimate it is. The best estimate is 0.70. That's your statistic. In this case, it's a p hat because they're doing how many out of a total. So like a fraction, proportion, decimal, percent, and here is your standard error. So once you have your standard error, you can go back to the handout and you can calculate that. Now, I'm not going to do that here in the video, but like what we did in 3.2, you're going to do your statistic plus minus your two standard errors, and you'll be able to calculate your confidence interval. Another way to also do it is you can click here on the two tail. And when you click this, it will also generate for you down here at the bottom what your lower and what your upper value are for the confidence interval. And it always will start off automatically with a 95% confidence interval. And I'll show you on the next couple examples how you can change that. But your calculation that you manually do should come out to be pretty close to 0.67 and 0.73. So you can use this just as a way to verify. The other example that we did in the handout was about the penalty, the average penalty minutes for hockey. And so they want us to use the bootstrap again, because there really is only one sample that's coming from the Ottawa Senators hockey team, but we're going to use them as a representative sample for like all of hockey. And we're going to generate 1,000 bootstrap samples, but this time we're going to use the confidence interval for a single mean. So be careful on your homework. There's opportunity to do proportion and opportunity to do mean. And so when I go back to the very beginning of StaKey, you'll see that you can run a confidence interval for a mean, and you can also do a confidence interval for a proportion. So this time I'm doing mean or average. And I need to make sure to select the Ottawa Senators penalty minutes. And so you'll see your original sample up here. It's 26 different players, and on average had about 24 minutes in the penalty box. But we want to run more samples based off of this one. So I'm going to hit the generate 1,000 samples, and there they all are. Again, these are all unique, different samples that are all inspired by the original sample. You also get your your statistic. It's estimating about 24.5, which is pretty close to what the original sample was suggesting. And maybe it's actually what the true parameter is. You also get your standard error, 4.841. So these are the two numbers that you would use. You would do 24.53 plus and minus 2 times your standard error, which is what we did in the lecture, but I'll let you do that for yourself. But this is mainly just to show you where you get these values from in StaKey. You can also check to make sure that your interval is approximately correct, that you've done your calculations correctly by clicking here on the two tail. And again, it's always going to start off immediately at a 95% confidence interval. And so you should get an interval of about 15.96 up to about 34.65. And every time you run another, if I were to wipe this out and reset and do a brand new 1,000 Bootstrap samples, notice it's always slightly different every time. So you still got about 24, but it's a little bit different in the decimal. The standard error is a little bit different because it's all randomly being done. And so you get still about 15 up to about 34. So it could vary for everyone who does this. It could be anywhere from like 16 to 33, 14 to 33. But this is, again, just a rough estimate of where the true actual average of penalty minutes is at. Now, the other thing that so that's going to take care of your 3.3. You'll do 2 examples of your own to show that you can generate your confidence interval using Bootstrap. The other thing that we did was with 3.4. And in 3.4, we were showing that what if we didn't want to do a 95%? What if we wanted to do something like 99 or 90% confidence interval, which is what is being asked for here. And so if you were to do this, there's a quick way to change the level of confidence. So the example that I'm doing here is here in, let me close that one up, back here in StaKey. And what I'm doing is the confidence interval for a single mean. And the example we're doing in lecture was the body temperature. And when you click on this, you'll see your original sample here that's estimating about 98.26. And so it's a lot like what we were just doing in 3.3. You're generating 1,000 Bootstrap samples. And when you click the two tail, it will always immediately assume that you're interested in a 95% confidence. But you can also adjust this to either a wider or a narrower interval by just clicking here on this blue box. And you can change it to 90, 99. Right now, I'm going to do 0.99 confidence interval. And when you click OK, it's going to widen it for you. And so, but it's still giving you where your best estimate of your parameter starts. So at 97.99 up to 98.527, that's where they think the actual true average for the human body temperature for a healthy individual is somewhere between 97.99 and 98.52, which is interesting because 9.6 is usually what's used in most medical settings. But that's how you can do a 99. Again, you can also really quickly, what if you wanted to do a 90? You can change it to whatever you want. And it's going to narrow it up and give you a 90% confidence interval of 98.08 to 98.43. The only other thing in this lesson was another example where they were doing the difference of proportions between women and men on supporting gun control. And so if you wanted to do a 90% confidence for the difference of those proportions, you can go to StaKey and notice when you're looking at all the different options for confidence intervals, there's also difference in means and difference in proportions. So play with both of these, but right now I'll show you the difference in proportions. And so they're trying to see if there's a difference between women versus men in supporting gun control, depending on whether you're male or female. And when you look at the original sample, you can see that generally does seem that female are more in support of a gun control law, about this much more, about 21% higher than men. But suppose you wanted to do a confidence interval of what the actual true parameter, where it's contained, you can do the same thing. You can generate 1,000 samples. And so there's all your 1,000 samples, and you got your standard error. Again, you could use this as your statistic plus minus 2 standard errors and calculate it yourself. You can also come here and click on the two tail to see what the confidence interval for 95% is. It looks like it's to be about 15.7 and 265. But to show you what 3.4 was about, we were like, well, what if we wanted to do a 90%? You can switch this by typing in 0.90, click OK, and it will give you what a 90% confidence interval would suggest, that the true proportion in the difference of women versus men who support a gun control is about 0.67 to 0.258, meaning women are that much more higher in proportion or likely to favor a gun control as compared to men. But I wanted to show you this, primarily the StaKey stuff. A lot of the hand calculations we can do with our calculator, but StaKey is what we're using to get our standard error, and also if we wanted to do 90% or 99% confidence intervals. But I'm going to go ahead and do one more thing here, which is in this handout 3.4. It's not something we did in lecture, but it's just to show you what happens if you have an original sample that's not ideal, meaning it's biased or it's heavily skewed. Then you should not use the bootstrap method to try to estimate a standard error for your confidence interval. So let me show you here. If this here is our original sample that's got values of 5, 6, 7, 8, 25, and 10. Let me show you in StaKey where suppose we're trying to estimate the average for something. So I'm going to go here to StaKey and do a confidence interval for a single mean. But I'm going to put in my own data, and I'm going to put in that data that we just saw: 5, 6, 7, 8, 25, and 100. So I'm going to use this as my original sample, and I'm going to click OK. So you can see over here that here's the original, what's being considered as the original sample, but it's definitely skewed to the right, or majorly skewed to the right. And so when you're doing bootstrap samples, again, all your new bootstrap samples are coming from the original. And so if you were to generate 1,000 bootstrap samples from this, look what kind of shape you get. It's definitely not bell-shaped. It's got like several different peaks to it. And so this would be a red flag that you've got a sample that's most likely biased, that should give you a red flag and say, don't do the bootstrap sample. You want to make sure that your original sample is a random sample, not influenced by major outliers. And so the ending for this lecture, this last part was just that we should say something like, it's got several different peaks. So it's not bell-shaped, and since it's not bell-shaped, we should not use the bootstrap method to try to estimate a confidence interval. All right, so I'm going to go ahead and stop sharing there and get this posted so that if you need this when doing your homework, I hope this helps.